Okay, so in this question we're given this function f of x equals a bit of an unusual way of writing the function. So it's not quite the same as a normal x and y function. So this is the function here. We're told that the domain of x is just from 1 to 5. So you can see it's a bit odd because it's written in terms of t instead of in terms of x, but there's an x up here. So what this is showing is that the function of x is actually the area under this t curve. So if I can draw this as just to illustrate what it is, I don't really know what the function looks like, but that doesn't matter. Let's say we're going from 1 to 5. So there's a curve, right? So here's a curve, 3t squared take 12t plus 9. And let's see, okay, so just kind of guess what the function looks like. No idea really what it looks like, but let's say it looks something like that. So this is x, and this is y, or f of x. So the function is actually showing you, it only goes from 1 to 5, and the value at 1, so f of 1, it's the area, so it's the integral, so it's the area under the curve from 0 to 1. So f of 1 is this area here that I've just shaded. F of 2 is the area up to 2, so it's all of this combined area. F of 3 is this combined area up to here, and so on. Okay, so you can see it's a little bit of an unusual function. So the function is not the curve itself, it's the area under the curve from 0 up until that point. Okay, so once we know that, then it's fairly simple to work through the parts of the question. So the first part says calculate f of 1 and f of 5. So in other words, calculate f of 1 and the two endpoints, because it only goes between those values. So, okay, pretty straightforward, right? So f of 1 is integral from 0 to 1 of 3t squared take 12t plus 9 dt. Okay, so now this is in the calculator section, so we can just plug that into the calculator if you wanted to, but let me actually do the integration for you. So 3t squared is, integral of that is t cubed, 12t becomes 6t squared plus 9t. Okay, plus a constant, but that we can forget about the constant because it'll cancel out when we plug in 0 and 1. So what have we got? So the 0 value is really easy because you just get 0, and the 1 value becomes 1 minus 6 is minus 5 plus 9 is 4. Okay, so f of 1 equals 4. F of 5, okay, plug the same values in. T cubed take 6t squared plus 9t from 0 to 5. And what do we get? So t cubed is 125. T squared is 25 times 6 is 150, so you get minus 25 plus 45 equals 20. So f of 5 equals 20. Okay, so that's the first part of the question. Okay, the second part is find the local min and max points of the curve. So again, like we're finding the local, when does this area become the minimum and when does it become maximum? So I've probably drawn that graph wrongly because it probably has to go somewhere below the x-axis for it to become a minimum, so it actually goes downwards. But we'll see. So the derivative of the function is, okay, so we know that the function, okay, so let me be careful about describing it here. The function is an integral, so the derivative of the function is this base function, but with x's in there, so it's 3x squared take 12x plus 9. Okay, so that's a rate of change of the function, happens to be just the function, the curve of the function. Okay, because the function itself is the area, so the derivative is actually this curve. Okay, so I hope that makes sense. Okay, so the derivative is, so let me actually take out some factors there. X squared take 4x plus 3, x take 1, x take 3. So local min and max are when that is equal to 0, so it's 0 when x equals 1 or x equals 3. Okay, so to find out whether it's a min or a max, we need to differentiate again. So the second derivative of this function is 6x take 12. Okay, so when x equals 1, That's -6. Therefore, this is a maximum. So when x equals 1. And what is the actual value? We plug that back in to the original function. Also, we've got the value here, 4. Okay, what about at 3? That gives you 3, 6, 18, take 12 is +6. Therefore, this one is a minimum at 3. And when you plug the value of 3 in there, we get 0. Okay, so that's the point of the function is 3, 0, which you can figure out by plugging the value of 3 back into, where is this function here? So there. Okay, so you get, plug the value of 3 and calculate it, and you get a 0. Okay, so that's the min. So the max is 1, 4, and the min is 3, 0. Okay, and then the last part of the question says find the global min and max. Okay, so this function, so the global is either going to be one of these 2 points, or it could be the endpoints. So let's see what we've got. So we've got, so it could be 1, 4, it could be 3, 0, or it could be the endpoints. So what are the endpoints? We've calculated them in part A. So f of 1 equals 4. Okay, we've already got that one. F of 5 equals 20. So we've got 5, 20. Okay, so what are the lowest values? So we've got 4, 0, and 20. So the min equals 0, because it's the lowest one. And the max equals 20. That's the highest one. And we're done. So, by the way, just one other thing as an aside. So how come we got this minimum? So how can there be a minimum at 3? So if you look at this, the graph that I've drawn here, I've actually got the graph wrong, because it looks like the area is increasing all the time. So because you keep adding, so for area up to 1 is this area here, then you add another bit, and another bit, and so on. So there actually isn't a minimum, or a maximum, in fact, or local. So the graph actually probably, remembering at 3, it's going to be 0. So the graph, okay, so again, we don't exactly know what it looks like. Okay, so remember the function at 3 is actually, the value is 0. That means that the curve is such that when it gets to 3, the areas cancel out. So we've got, you know, something like, I don't exactly know what it looks like, but maybe something like this. Okay, so at 5 is going to be 20. So that means that the function at 3 is 0, which means that the total area must end up being 0. So let's say something like that. So we've got this bit here has to cancel out with that bit there to give you a 0. Similarly, the point 5 is going to be 20. So now these values have added up again. So when you add up all the areas from 0 all the way up to 5, it's got to end up with a total area of 20. Anyway, that's just a bit of an aside to explain how you actually get a minimum here of 3, 0, rather than what I've done up here, which is that the function just keeps increasing all the time.